Yo. Sorry, I was just like trying to play around and I wasn't even sure it was on, but we're recording now. So what's up? What is up, yo? Math. Math. Today we're looking at a whole nother video. Oh, my voice sounds so hoarse. Um, anyway, hey. We're looking at a video today with some math. We're talking about fractions. We're talking about quotients of fractions. We're talking about problem solving with quotients of fractions. Today we're going to look at this one problem. I guess I should have been writing this stuff down. Sorry, my hand was held. My hand was held? My hand was not held. I was holding a cup of coffee. What are we talking about? We're talking about quotients, and, oh yeah, fractions. But what happens when we get into these word problems? Because it's really hard to make sense of like everything that's going on. And so today we're going to kind of talk about like how to unpack a problem such as this, that I'll read in a second, so that we can make sense of like when we do what. So let's kind of dive into it. It says today our one problem we're going to look at, this whole video revolves around this one problem. It says that Tamara, good old Tamara, good friends with the farmer that we always see in our word problems, needs tiles to make a border around her bathroom wall. The border will be 9 feet long and 1/3 foot wide. Each tile measures 1/3 by 1/3 foot. Each box contains 6 tiles. How many boxes does Tamara need? Okay, so already so much information. So, sorry, I had to take a drink. I'm gonna be drinking some coffee on this one. Let's dive into it. So when we think about problems like this, right, we're always also thinking like, what do we do? Like what happens? What am I multiplying? Am I dividing? Like, what is the math that goes on? So I think, as always, when I try to break things down, I think the first thing is really try to draw it out. So make some pictures so that you can make sense of what's going on. I think that's the first step. And while you do that, I guess maybe this is the first step, but I'm gonna call it the second step, is really do it a sentence at a time. Sentence at a time. And then from there, I think that's where you could start to set up some equations or well, I guess drawing it out as the models. Equations. Oh boy. Oh wow, what a morning. Equations. Oh boy. Let's try that again. That's where rewind. Um, that's where you're doing some equations to help you like make sense of like the math that's going on. So let's just play with that. Let's think about it. Again, like I said, one sentence at a time as we draw it out. So if we look at our very first sentence here, it says that, let's see if I can get a little thinner. Let's go with a little green. It says here that, Tamara needs tiles to make a border around her bathroom wall. Okay. So step one, like that's what we have, a bathroom wall. So just stop and think like bathroom wall. And if you got your journal in front of you, I'd draw that out. And I'm actually going to move to the next page to do that. I think I'll jump back and forth on this, but if I'm thinking about a bathroom wall, well, okay, I'm gonna just draw out a little wall. Okay. Um, got that. Check. Now, next it says the border. Oh, okay. So yeah, if I go back to that page, like that border, again, if we think about border, that's just like outside, right? So like if I have a border, I'm kind of doing this. So what it's really saying is that she's gonna put tiles like around it. Tamara's gonna like tile things out this way. So the tiles aren't covering the whole wall, but there's a border, right? The thing that goes around it. Which I think at first one might think, oh, well, that sounds like perimeter because it's going around. And yes, but at the same time, as you notice, there is still some thickness to it. So we're really looking at the space that this border is taking. Okay, so I already got things drawn out. I'm feeling good. We're gonna go back. Um, let's go to the next sentence, right? Thinking about one sentence at a time, and that says that the border will be 9 feet long by 1/3 feet wide. Okay, so a couple things to pop out to me. I see width and length. So I'm already thinking area. So even if I can't really like measure this out on this picture, it is really telling me that it's actually giving me the equation, right? Equation for this border, because it says, oh, it's 9 feet by 1/3 feet. So we've talked, oh, what? Hi. Oh, we talked about how by is that multiplication. So I have 9 by 3 for starters. So to find my border, and maybe again, I'm gonna put B for border, right? We think about drawing out those equations to help us think. That's kind of the first thing I'm gonna do. I'm gonna figure out like how much space does this border take up? So I'm gonna do that. I am literally going to do that. So if I take 9 times 1/3, that is 9 groups of 1/3. So 1/3 plus 1/3 plus 1/3 9 times, or 9 times 1 is 9/3. So I have 9 1/3 pieces. And again, if multiplying fractions is something you're like, I'm not sure about, like go back and watch the other videos. Remember, a lot of times in progression of this, I'm under the assumption you've seen the other videos, you practice this other work. And if not, totally fine. Go back, check out the other videos. It's all good. All right, well, we have a top-heavy fraction. So I'm just going to do that work. This is really the same thing as 9 divided by 3, which is the same thing as 3 feet. So our border is equal to 3 feet total in area, right? So all this just takes up 3 feet total. I'm not really sure where I would write the measurements or make sense of that, but that's okay because they gave me that equation to just make sense. Okay, so we have a border that's 9 feet. Now, what we're gonna do is, again, we draw it out and think about what's going on according to this. And if you want me to go back, I will, because I did say we should read it sentence by sentence. So sorry for not following the rules. It says here that each tile that we're going to put around it is 1 foot by 1 foot. So again, that by word, oh, I guess it didn't say by in the first one, didn't I? Aha, good assumption. I was right. 1/3 by 1/3. Again, that's another piece of area. So these tiles, and I could draw this out. I'm thinking I have like these little tiles that I'm putting on, right? And I'm gonna like, here's a tile, here's a tile. And this works because if you remember, they said the tile is 1/3. I don't know why I keep drawing it. I'll just do it here. 1/3 by 1/3. So what's good is the width of our border and the size of our tiles are the same. So that's pretty good. Having 1/3 and 1/3 makes this problem pretty compatible. But what it is saying, oh gosh, these are getting so tiny. Let's see, I'm gonna put it over here. What it is saying is I have this tile. I'm gonna erase these other ones. Sorry, I was like, so many tiles. Which is true. How many tiles do we need? We have this tile that's actually a square shape because they said 1/3 by 1/3. So, and that's what we're doing. We're just like, how many of these tiles would go around this border for Tamara's wall? Because she loves tiles. She loves, Tamara is all about taking walls, building borders of tiles so that when Tamara looks in the mirror, she's so happy. Just kidding. Anyway, let's get back to the tile. Okay, so we're putting these tiles around, and these tiles measure 1/3 by 1/3, which is 1/3 times 1/3. So the area of a tile is 1/9 of a foot. That's how much space it takes up. Okay, and okay, so now we have 2 things. Oh boy, I'm gonna go to a 3rd page. So now we have 2 things going on. We do know that our Oh, hello, pen. Our border is equal. Wait, what do we know about it? Oh, 3 feet. I was about to say 9. That would have been crazy. Our border equals 3 feet because we found that by multiplying and finding the area of it. Uh-oh, I'm getting laggy. Oh no, come on, pen. We don't. Hold on. Okay, sorry. Oh my gosh, so laggy right now. Come back. Okay, here we go. Recover. Oh, dude, come on, right. So we know our border is 3 feet, and we know that the tiles, I'm gonna call that T, is 1/9 of a foot. Okay, and again, if we go back to that picture, we have this border that's this inside part here that's 9 feet total. And we got to figure out how many 1/9 foot tiles will go into it, right? And again, if you draw that picture and think about what I'm doing, I am distributing right here, right? I am thinking about how many of these pieces would go into 3 feet. So to find my final answer, I'm gonna call it A for final answer. I gotta take this 3 feet of space that we have, and we're gonna divide it by the 1/9 pieces to figure out how many tiles we need. Oh, this isn't even the final answer. Boy, I need to follow my own rules. So let's go back to page 1 and reread each sentence. It is the right step. Sorry, I've read this. Oh yeah, each box contains 6 tiles. So how many tiles do we need? So that's the next step. So first we need to figure out how many tiles we need, and that's what this is going to tell us. So let's see here. If I'm going to do a third divided by 1/9, then I'm starting with 3 holes. So I'm gonna model 1, 2, 3 holes. And I know that I'm cutting each one into 9 pieces. Oh, that's like 6. Huh, hold on. Let's start over on that one. So I got 9 pieces in each one of these. So that would be a third this way and a third this way. 3, 6, 9. There you go. So I get 9 pieces in each, or I can, again, we've talked about this, how I can just label 9 pieces. So 3 holes at 9 pieces each means I need 27 tiles. Okay, so we're still not done. Think of all the things we've done already. First, we had to find the area of that border. Next, we had to find the area of the tiles themselves. And then we divided that. We took the area of the border, which was 3 feet. We divided it by 1/9 of a foot to figure out how many tiles we have. We have 27 tiles, but that's not the end of it. So this is crazy awesome because I'm going to add a page and we can already see that we are doing so much work for one problem, which is great. This is like that 5th grade level of work. Like we're getting ready for middle school. So here we go. So we know we have 27 tiles. What I'm going to do is go up and I'm going to read that last bit. And I'm going to ask you to hopefully pause this and think about how you're going to solve it and what your answer is going to even be, because that's a whole nother thing. And then we'll walk through it together. So we're gonna go back. We know we have 27 tiles, but here's the question. After all that work, the question is literally asking, and this is where the question mark finally comes in, is how many boxes of tiles does Tamara need? We know she needs 27 tiles, but they're asking us how many boxes, and it says here that each box contains 6 tiles. Okay, so we have, I'll restate this, but I'm gonna go back to this page here. We have 27 tiles that she needs, but we also know the question is going to be about how many boxes. And we know that 1 box is equal to 6 tiles. Well, we would know that if the pen was working. There we go, 6 tiles. So thing about that is put me on pause, solve that problem. Okay, you're back, right? You paused. I love that. Thank you. So let's see what you did. So 27 total tiles, 6 tiles per box. How many boxes do we need? Well, when you think about this, and there's so many different ways to do this, but I'm gonna go kind of that 6th grade approach where like that T-chart and thinking about like what's my rule, what's my input, my output might help us. So I'm gonna think boxes and I'm gonna think tiles. So if I bought one box of tiles, I would get 6 tiles. If I bought 2 boxes of tiles, I'd get 12 tiles, right? And what we need to know is how do we get 27 tiles? So then again, how many boxes would that be? So this is where you can think about that input-output approach to things. This is that next kind of level, right? And if you look, if I'm here and I'm trying to solve for here, then I can use this upper part as my rule. And my rule states I start at 6, I get to 1. So I'm definitely getting smaller. So that's either going to be a rule of dividing or subtracting. It doesn't make sense to say 27 minus 6, or anything, right? So I think we definitely are on division. And if I look here, 6 divided by something equals 1. And so actually that would be 6. 6 divided by 6 equals 1. So my rule states I'm dividing by 6, right? Because look at here, 12 divided by 6 equals 2. So that would make sense. So we're going to take 27 and divide it by 6. So I hope that that's what you did. And then we'll also, God, I got to go to a 5th page. This is great. We'll talk about what the answer is. So let's add another page, and we're doing a pen here. 27 divided by 6. Let's see, I'm gonna go here. Let's see here. 6 times 4. I guess I should be changing up some colors here. 6 times 4 gets me 24. I have 3. That's a leftover, so that doesn't work in terms, right? So like this is what we know. I know if I get 4 boxes, I'm going to end up with 24 tiles. So if you think about an answer, we have 4 and 3 6 boxes. But I don't know. Have you ever been able to walk in the store and be like, "Oh, can I get 3 6 of that box? I'd like to just have 3 6 of that that the bag of Takis," right? So we can't do the 3 6 of it. We actually then need to round up, because if I bought 4 boxes, I'd only have 24 tiles, and that wouldn't be enough. So it looks like to me I have to buy 5 boxes, which would actually give me 30 tiles. But that's okay. I'll have some left over, and at least that's better than not having enough. So final answer to all this is we need 5 boxes. And again, remember how we label that, we'll circle that. It's separate from all the other work we're doing. See how I put it out here? And that's that. So that's the work we're doing today. And that was a lot of work on one problem. So don't worry. When you think about getting back into it, I'm going to go all the way back to page 1. This is the concept today, right? Read through it, draw it out, do a sentence at a time, and then start to build equations to help your picture and think of it. Because we just took a problem today and we did multiplication of fractions, division of fractions, and then we ended up doing division of whole numbers just to get the answer. So we did 4 different steps to get this one answer. So I'm gonna leave you at that. That's it. Keep up the good work. Remember how it always works. If you have questions, keep asking. Ask until things make sense. That is a math norm. Don't ever settle on this doesn't make sense and I'm just going to push it aside and move on. There are answers out there. It's the coolest thing about math is keep exploring till you find those answers. And we will see you next time.